Hello, this video will be about nomenclature of ionic, covalent compounds, and acids, and we're not going to worry about naming hydrates. So the first type of compound you might see is naming binary ionic compounds. So binary meaning containing only two elements. The positive ion is always written first, and that has the same name as the element. And the positive ion is going to be the metal, the ones to the left of the periodic table. The negative ion, called the anion, is written last. You take the first part of the element's name and change the ending to "ide." So for example, bromine would become bromide, oxygen would become oxide. You need to know if an element forms cations with different charges. So you're going to want to look at that periodic table of ions that we gave in class and look at the elements that have more than one possible ion charge listed. In general, it's the transition metals, but there's some exceptions to that. So the main ones you'll see are, copper, iron, nickel. There's also lead and tin, which are outside of the transition metal area. So you need to know which elements form more than one charge of ion. For those elements, you will need to use Roman numerals to specify the charge of the ion. So for example, if you're given the formula CuS, you would write the name as copper 2 sulfide. And the way that you figure out the charge of the cation, your metal, is to look at what it's bonded to. So in this case, you have one copper and one sulfide, and you know that overall the charges have to add up to 0, and you know that sulfide is -2. So the only way for that to work out is for copper to have a positive 2 charge. So your positive, negative charges have to add up to 0. A few more examples here. If you had CuBr, the name would be copper 1 bromide. Again, you're looking for the charges to add up to 0. Bromide has a charge of -1, and in order for one copper and one bromine to have a charge totaling 0, copper must have a charge of +1, so it's copper 1 bromide. Fe2O3 is iron 3 oxide. So this one, you've got 3 oxygens. Each oxygen has a charge of -2, so that means you have a total negative charge of 6. That means your 2 irons must combine to give you a total positive charge of 6. The only way that can happen is if each iron has a charge of +3. So again, the Roman numeral tells you the charge of the metal. You only use Roman numerals when metals can have more than one charge, and look at your table, the periodic table of ions, to figure out which metals those are. If you want to pause the video, you can pause it right here and try these practice problems on a piece of paper. And I will post the answers up here. So the first 3, notice no Roman numerals needed. Number 4 contains iron, which has more than one possible charge, so you need a Roman numeral there. And 6 and 7 both also need Roman numerals. If you were to put a Roman numeral in a problem such as number 1, if you were to call it lithium 1 fluoride, it would be incorrect. So know when to use the Roman numeral and when not to. Polyatomic ions. So some of these ionic compounds will contain polyatomic ions. We have a list of them that you've been provided. You just have to memorize what they are and what their charges are. So know the names of your polyatomic ions, the formulas, and the charge. For the polyatomic ions, you just use the name that's assigned to it, so you don't change the ending to "ide." So for example, CO3 -2 is the carbonate ion, so if you see the compound CaCO3, you name it calcium carbonate. Don't do anything else to the name. Ammonium is the only polyatomic cation you need to know. All the other polyatomic ions are anions. You have a big list of polyatomic ions that might be intimidating, but there's some things that will help you remember them. And one thing to point out is only 3 polyatomic ions end in "ide." That's cyanide, hydroxide, peroxide. If you see anything else ending in "ide," it's going to be a monoatomic ion. For example, magnesium chloride is based on the chloride anion, just Cl. Other endings for polyatomic ions. You might see ate or ite are the 2 other common endings for polyatomic ions, and there's a system for naming oxoanions. These are polyatomic ions containing oxygen, which is many of the ones that we see. And you will notice that if you know what the ate version of something is, for example, let's say that you know that the polyatomic ion chlorate is ClO3 with a -1. You should then be able to use this system to predict the formulas of related polyatomic ions. So for example, if chlorate is CO3, chlorite would be ClO2, hypochlorite would be ClO, and then perchlorate would be ClO4. So the way the system works is the ite version of the anion has one less oxygen in it than the ate version. The hypoite version has 2 less oxygens in it, and then the per-ate version has 1 more oxygen than the ate version. So you want to look at these oxoanions as groups. There'll be groups of things like bromate and bromite, or chlorate, chlorite, hypochlorite, and think of them as, group them together when you're trying to remember them, and realize that there is a pattern in how they are named. So if you can memorize what the ate version is, you should be able to figure out what a lot of the other ones are based on this general pattern. Here's this example I was talking about with chlorate. So chlorate ClO3. The ite version has 1 fewer oxygen. The hypoite has 2 fewer oxygens, and then the per-ate version has 1 more oxygen. Here's another example here with sulfate, sulfite. There's nitrate, nitrite. So knowing this system should cut down on the amount of true memorizing you're having to do with your polyatomic ions. Here are some practice problems. Again, you might want to hit pause at this point and practice these problems, and then I will post the answers. This last one, I'll point out, acetate is shown differently in many different places. Some books write it like this, CH3COO. On our list, I wrote it as C2H3O2. So just kind of keep an eye out for that. You might see it written in different ways. Recognizing ionic compounds. It's important when you're naming a compound, you have to recognize whether it's ionic or covalent, so you know which set of naming rules to apply to it, because we name them differently. So ionic compounds will contain at least one metal and a nonmetal. Writing formulas for ionic compounds. Ionic compounds are neutral, so all the charges must add up to 0. And there are certain elements that you should know the charges of. Again, refer back to your periodic table of ions that were given in class. Things you want to know is, for example, all the alkali metals are +1, all the alkaline earth metals will form a +2 charge, all the halogens will form a -1 charge. So there's some common ion charges you should know. Here's an example of writing an ionic formula. Let's say you're given the name calcium chloride. You want to first ask yourself, what are the charges of the ions involved? So calcium will always form a +2 ion. It's in group 2, your alkaline earth metals. And chloride will always form a -1 ion. It's a halogen. So when you put them together, you'll need 2 chlorines to balance out the charge of 1 calcium. And a simple way of figuring out what the correct formula is what we call the crisscross method, which is shown here. So if you take the numerical charge of the chlorine and make it the subscript for your calcium, and vice versa, the numerical charge of the calcium, make it the subscript for your chlorine, you're going to end up with basically the lowest common multiple of their charge, and that will result in having a compound that's neutral. In some cases, you'll find you'll have to simplify it. So keep in mind, ionic formula will always be an empirical formula, so it should be the lowest whole number ratio. And we never show the number 1. So notice we just wrote calcium, not calcium 1. Another example, let's say it was iron 3 sulfate. Remember, if you see a name like this, the Roman numeral is telling you the charge of the metal. So I would write down what your ions are and what their charges are. So iron has a charge of +3, sulfate has a charge of -2. If you do your crisscross method, you'll see 2 irons and 3 sulfates will balance out and give you a neutral compound. Notice that will give you 6 positive charges and 6 negative charges. The other thing to notice here is when you have when you want to say that you have more than one of a polyatomic ion, it's important to put parentheses around that polyatomic ion and have the subscript outside of that. So you'll see the SO4 is in parentheses, the 3 is outside that parentheses. That means you have 3 of whatever is inside that parentheses there. Again, take a moment, pause the video here, and do these practice problems. With writing ionic formulas. And I'm going to pause here and we'll have a separate video for covalent and acids.